It most preferred to use popular L293 boost motor driver for running DC motors and stepper motors like this for your favorite RC car or line follower robot projects. This motor only consumes few hundred milliamps at no load condition and consumes maximum of 2 amps at full load condition, as you can watch in this video. But for controlling high current DC motor like this, which could be used for driving a wheelchair or some lifting application, this L293 would not be sufficient, because at no load condition this motor consumes almost 2 amps and at full load condition this exceeds up to 12 amps, while our L293D only could deliver up to a peak current of 2 amps. So this video will let you learn about designing a 42 amp MOSFET based PWM DC motor controller which could be used for a wide range of applications. This circuit can be used to drive a motor in both clockwise and anti-clockwise direction and also control the speed of motor too. I will use a simple joystick interface with Arduino for demonstration purpose. To make this circuit, you will need 2 N-channel MOSFET. I here use IRFP150 and power MOSFET which have a maximum drain current of 42 amps, which is used to drive the DC motor or inductive loads, while P55NF06 N-channel MOSFET is for driving the gate voltage of IRFP150N. You can use any MOSFET based on your current requirement, but refer datasheet before proceeding. Other components are 6 ampere diode, some resistor, any Arduino flavor, and joystick module. To design the circuit I done, you should have some basic knowledge about MOSFET. Find the pinout of the MOSFET from the datasheet, and it is very crucial to use the right pins to avoid the smoking out of MOSFET. MOSFET are available in 2 types, N-channel and P-channel MOSFET. They have 3 pinout, drain, gate and source, which is similar to the collector, base and emitter of a bipolar junction transistor. To use MOSFET as a switch to turn on something as like a LED here, we must connect LED or load to the drain terminal of N-channel MOSFET and then apply a gate voltage to gate terminal. Never exceed the maximum gate voltage as listed in the datasheet, and also the load current should not exceed the maximum drain current. By making a circuit with a LED and connecting a resistor to the gate terminal to avoid excess gate voltage than the rated gate voltage, then applying a positive voltage to the gate terminal from a lead acid battery pretty much turns on the LED. But there is still some problem, as you can watch. Even a touch with my finger turn on the MOSFET. It is due to the high input impedance of MOSFET, which causes MOSFET to draw only very small gate current to drive its output, unlike bipolar junction transistor. So a pull down resistor like as shown in this circuit must be connected to the gate terminal, which will always provide a small negative voltage, which in turn off the MOSFET at normal conditions. By adding a pull down resistor, I solved that problem, and also by giving a variable voltage at the gate terminal using PWM from my Arduino, I made a simple LED light dimmer as shown here. Unlike N-channel MOSFET, P-channel MOSFET need a negative voltage at its gate input to turn on, and the load is connected to the source terminal as shown in the circuit. Here, instead of a pull-down resistor, we will use a pull-up resistor to avoid fast triggering of MOSFET. This circuit shows the implementation of PWM controller without direction changing circuit for the motor. Here, P55NF06 MOSFET drive the gate of the IRFP150 and power MOSFET which control the DC motor. Here, I made 3 similar control circuits for my application, but for this video demonstration, I only use one of them. Here you can watch 10 amp DC motor is connected to the driver circuit, and later I replaced 220 ohm quarter watt resistance with 100 ohm 1 watt resistance due to the heating problem. For powering up the circuit, I used 10 amp 12 watt transformer along with a power bridge rectifier as shown in this video. Here, this joystick will control the speed of the motor. As I move the joystick module, you can watch the motor is slowly turning on and attaining to the full speed. Okay, it's time to move on. To control the direction of rotation of DC motor, I implemented this circuit where a double pole double throw relay is used to switch the terminal of motor between drain and supply voltage, as you can see from the circuit. Since I have no DP-DT relay with me, I used 2 SPDT relay to make the circuit. Here, using popular BC101 transistor, I turned on and off both relays simultaneously and connected base of BC107 to a digital pin on Arduino. As like always, you can find link to all circuit and code in the description of this video. I clamped the DC motor on the workbench with a C-clamp, and here moving up the joystick will make it rotate clockwise, as you can watch on the video, and speed can be increased gradually. Like moving down will rotate the motor in anti-clockwise direction. Also can control or vary the speed slowly. I purposefully set a delay of 1 second while switching between direction of rotation to avoid huge back EMF produced by the motor winding, as motors are generally inductive loads. For the same purpose, I use power diode across this MOSFET. Talking about relay could bring the viewers an imagination about their power consumption. So here is a simple experiment for finding how much power this 12 volt relay can consume. Here I hook up the relay to my self-made variable lab bench power supply, and setting up the voltage, it only consumes about 27 to 28 milliamps, as you will watch on the green multimeter on the left, while corresponding voltage on the yellow multimeter on the right. As we know, power is equal to voltage into current. This yield only about 338 millivolt and total of 676 millivolt for 2 relays I used. You could use 5 volt relay for more better result, and also for direct control with Arduino. This circuit would be helpful in many projects, and also this is one economical method for high current control. Thanks for watching. If you like the content of this video, please like and share my videos. Don't forget to subscribe for more videos. Put any doubt and suggestions on the comment section below. Goodbye.